Hello, everybody. Welcome back. So in this video, we are going to learn about another example of a class. And this example is going to, unfortunately, be a little bit more mathematical and a little bit less adorable. So what we're going to do is we are going to construct a 2D vector class. This is going to allow us to add and subtract vectors. So we note that we might want to be able to take in the tuple 1, 2, and the tuple 3, 4, and get this to print, well, 1 plus 3 is 4, and 2 plus 4 is equal to 6. We might want that. And for here, if we wanted to multiply 3, 4 by 2, we might want this to become equal to 6, 8. Unfortunately, this is not what's going to happen when we try to run this code. When you take a tuple and you add it, it just concatenates them. And when you multiply it by 2, it just concatenates it with itself. So we're going to create a new class, which is going to be a list-like object, or a tuple-like object, which is going to let you get this to behave the way we might want. Something which is worth noting is this is an exercise that's meant to be educational, and there are actually better ways that are pre-written for you. So this is not a real-world thing. We're going to learn about the NumPy class, or the NumPy module, very soon. But let's get started. So our class is vector. Okay, and the first thing we need is we need an init. When you use an init, the first variable is always self. And we said this is going to be like a 2D vector. So we're going to have two other variables, which are called x and y. And we're going to set self.x equal to x and self.y equal to y. And let's go ahead and first write our scalar multiply function. First variable is always self, and then c is going to be the factor we are scaling by. Oops, I forgot the colon. Okay, let's go ahead and document this bad boy right away. Returns itself multiplied by c, i.e. changes xy to cx, cy. Okay, now this actually, we can do this a couple of different ways, but the easiest is just to return, and we're returning a vector, and we're returning a vector whose first argument is equal to c times self.x, and whose second variable is equal to c times self.y. So now we can go ahead and we can say v is equal to vector 1, 2. And we can check that the v.x is equal to 1 and v.y is equal to 2. Oh, sorry. v.y is equal to 2. I was typing what I was saying. And we can add in, we can say u is equal to v.scalar multiply by 5. And now we can check that u.x is equal to 5 and u.y is equal to 10, because 10 is 5 times 2. Now, what we would really like to be able to do, though, is rather than printing v.x and v.y, it'd be nice if we could just do this. But that doesn't work yet. Or, I mean, it works, like it doesn't throw us an error, but it doesn't do what we probably wanted. We probably wanted it to print 1, 2, maybe with some like fancy brackets or something. So let's go ahead and let's betterize our vector class and give it the behavior we want. Okay. So we need to add a function which prints. So it's going to be, we're defining a print function. And printing the objects of your class is something that's pretty darn common. So there's a magic method which is automatically set up to help you print stuff. And this is the straw magic method. Because, you know, one of the common things you print is a string. So it effectively stringifies it, you could think. And the one thing it's going to act on is the object itself. And we're going to return. So here's how I like to write vectors, with a bracket plus, okay, so we're going to write self.x plus comma plus self.y plus square bracket. And this isn't quite right yet. And it's the str magic method, so we want it to return a str. And this is a string, this is a string, this is a string, so we should turn these into strings. So now let's make v a vector. And let's try to print v. Ta-da! And we can go ahead and we can say u is equal to v dot scalar multiply by 5. And we can print u. So what doesn't work, though, we're making progress. I want just to be able to type u plus v and have things add up. Sad. Unsupported operand types for plus, vector, and vector. So that's kind of a bummer. So we need to come up with a way of adding this in. And so this is going to be with the add magic method. We're going to use the add magic method and the sub magic method. Using the add and the sub magic method is essentially the same thing as operator overloading in C++, if you're familiar with that. Typically speaking, that is something which is covered in 10b, not 10a. So many of you guys are coming here directly from 10a, so you might not have seen this before, but if you have taken 10b, this is operator overloading. So the magic method for adding things is called add. So it's def underscore underscore add underscore underscore self, and then there's going to be another object we're adding. And so we're going to return, and we want to, if we're going to input two vectors and add them, we should probably return a vector. And the entries of the vector should be self.x plus other.x, comma, self.y plus other.y. And now for if you use the add magic method to add, then unsurprisingly, we're going to use the sub magic method to subtract. And the code here is almost identical, except we are changing all of the pluses to minuses. So now let's make two new vectors. Let's call them u is equal to vector 3, 6. And v is equal to vector 2, 4. We'll set w equal to u plus v and z equal to u minus v. And now let's print all of them. And we can see that our vector addition and our vector subtraction is working exactly as we would expect. So as usual, the last thing we need to do is we need to document. So far, we've written a beautiful class, and if you turn this in on your homework, I would take off a ton of points. That's not good. You should always document stuff. Okay. Okay, so first let's document the class. A class which models 2D vectors is equipped with addition, subtraction, and scalar multiplication. Okay, scalar multiply we've already documented, so maybe we wouldn't have lost all the points. And I do think that these other magic methods are mostly pretty self-explanatory. For the str, maybe let's say a little bit. Let's say prints the vector in format x comma y with the nice brackets. Some people don't like the brackets. I like the brackets. And now we can look at our docstring. So if we wrote this class for somebody else, we can just say, okay, vector. It's a class which models 2D vectors. Hooray. Vector dot str. Create a oh, that is just the str class. We have to type in vector dot str. Sorry. And we have to type in underscore underscore str. And now after we type things in correctly, we can now look at our beautiful documentation. And once again, this is a basic reminder that Python is a wonderful, powerful programming language. However, it only works if you type things correctly. All right, that's it for today. I will see you guys next time.